Welcome to our first ever JFrog LinkedIn Live event. I'm Sean Pratt, your friendly marketing manager. I'm here with Bill Manning.
Hey guys, how you doing?
Awesome. And we're here to talk about our recently announced Software Artifact State of the Union report. If you haven't checked it out, I think it might flash on the screen, or a link to it at least. Go look at it real quick while we banter and warm ourselves up a little bit.
In this nice between two ferns almost looking kind of set here. It's
between three palms.
Yes, we'll go with that instead.
Awesome. So if you haven't checked out the report, please do so. It will be helpful so you understand what the heck we're talking about here.
There we go. A little flash.
It's free. It's online. It's not gated. Go to the link and check it out. But before we get started, let's get to know Bill a little bit better, because he's really the star of the show. I'm just a talking head. He's the person with a brain. Bill, is it fair to say that you're a technologist?
I guess we'll go as far as to say that. I mean, I've been called worse, so I mean, absolutely.
Are you
doing this for a long time, obviously, with this little white on my face.
Are you a coder at heart?
I am completely a coder at heart. It started that way. I still do it to this day. I'm fortunate enough to actually have that as part of the things that I do here at JFrog, which is, besides educating, I need to learn myself. So being a technologist is constant learning, and that's what I love to do.
Awesome. So Bill is definitely qualified to talk about this report, share his insights, which is going to be helpful because I don't know anything. But another fun fact about Bill is that Bill and I are actually both from Long Island originally. So Bill, a very important question to know for any Long Islanders who might be watching. What's your go-to bagel order?
See, for me, it's in my hometown of Oceanside, New York, and it's the 24-hour bagel deli. Any place that you can get a bagel at 2:30 in the morning and have the best bagel, and it's all good for me.
Awesome.
Now we won't get into the pizza debate because that's a highly contested thing.
We might come to blows if we get into pizza.
But we're both from Long Island. That's the only time it ever comes out was when I say the word Long Island. So,
there you go.
All right, let's kick this bad boy off.
Let's go.
Let's talk about packages.
Let's talk about packages. For those that are watching, if you have questions, please throw them in to the chat or however it works with LinkedIn Live. Again, this is our first time doing it, so ask questions. We'll get to them. I have a bunch of questions for Bill, but we'll also take your questions and we'll have some time at the end for that.
Yeah.
So let's get started with the first question here, Bill. So it's about polyglot development. We saw that there was an average around 7 technology types that people use in their SDLC. But that goes up to 20 plus technologies. Do you expect organizations to consolidate around technology types over time, or is it going to continue to be super flexible?
Flexibility is actually the key aspect behind this, right? The thing is when corporations, and especially when you have coders and architects who work on software, you always want to make sure you use the appropriate stuff for what you're trying to build, right? You're not going to use one technology over another that, say, we'll give an example, we'll talk about later on in more detail, but, say you're doing things like IoT devices. When we get into this a little later on, you might, use C and C++ because of its low-level abilities. In the past, with a lot of these IoT devices, it used to be things like Java, right? You use a framework called OSGI, and now that's kind of evolved into stuff like Rust, right? Because Rust has some stuff, and we'll talk about how Rust has increased over time. But you pick the technology that best suits the actual problem you're trying to solve. So, web-based technologies use things like Docker images with Kubernetes for scale, and use things like NPM, maybe with React.js or something else. Or if you're going with more of a back-end type of system, you might use something like Java, or you're doing something like, say, machine learning ML, you might go towards Conda or Python. So the thing is that the package types really are dictated by the problems that the companies are trying to solve. So most companies are polyglot because they want to use the appropriate technology for the appropriate problems they're trying to actually solve.
Awesome. That makes total sense. So do you think that the flexibility and the breadth of technology types leveraged by a given company, is that what's driving the large volume of artifacts that organizations have to manage?
Well, it's a combination of that, and also too the fact that we've all known how DevOps has taken over since 2006 when the CTO of Amazon came out and said you build it, you run it. And the thing is that when we start looking at the increases, because the number of builds are increasing, right? It's better to release smaller features more rapidly, as quickly as possible, as opposed to the days when I started back in the 18 days when we used to do quarterly releases, 2 weeks of planning, through a month and a half or so of coding. Then we go in and we did testing. Now it's all become this automated world where you check in your code, it auto builds, it tests, it does the functionality behind the scenes, and it releases. Right, faster releases are better for companies because it means they can get the features to their customers faster. And what's really nice about that is that with these frequency of releases, that does mean increasing the number of things being used, the number of builds being built, but it also means that companies, like I said, are able to attribute to their users to provide them with the best solutions, best fixes, best performance increasements, whatever, more rapidly. So yes, the frequency does increase, and it will increase over time, and that will constantly be that way.
So what I'm hearing you say is that exponential growth in artifacts to manage is going to happen.
It's going
to be the norm. You're going to have more stuff that you're just kind of managing in your system.
Right, exactly. Now, later on, we'll talk about some of the other things where the methodologies are changing, where things are getting simplified. But in terms of the number of builds, the number of packages, things like that over time, that will still stay relatively the same or will actually start to increase. We've actually already exponentially seen it grow, right? Just because, like I said, the frequency of releases. But at the same time, I think that's going to stay steadfast over time.
Awesome. So I want to shift gears a little bit, talk about a topic that's very buzzy, cloud native. Everyone loves cloud native. I love cloud native. So we saw massive usage of Docker. I mean, it's blown up. I mean, I think it's fair to say that it's mainstream adoption. It's being used.
Oh, it's already mainstream. That's actually gone way above and beyond that.
Yeah. And when we see things like Helm usage going up, we just launched Terraform support last year, and that has had some of the fastest adoption of a package usage in our factory that we've ever seen. Why are folks going this route? Why is cloud native so popular?
Oh, absolutely. I mean, well, if we go back to some of the core tenets of the reason why, first of all, why Docker came into prominence, right? Docker allowed virtualization, right? It allowed control of the environment for the deployment of software. That got adopted by things like 12-factor, which is one of my favorite development methodologies, which is the idea is that you remove that factors of it works on my machine. And by doing that, 12-factor adopted the methodologies of actually using Docker images to do coding, right? So the same OS that you're building on is the same OS you'll be deploying into production. And so the thing is that the next part of this was, of course, orchestration, which is how, there was Docker Swarm first, right? How do you attribute to scale? And then, Helm came about, right? And we're very steeped into cloud native. And the idea is virtualization, orchestration of environments allows for attribution for things like rapid demand, scaling up, scaling down, being able to deploy new services, because Docker allows you to build smaller services so they're more manageable. And then Terraform came in and allowed for more rapid ability to go ahead and change the infrastructure, right, on the fly. So this way you can change attributes and values in the way things are executed in runtime. This is very attractive to a lot of corporations because in the past you'd have to go buy a lot of servers, right? I remember the days of actually having to go and purchase servers so we could have increased demand back in the .com era, right? And then over time, now it's now you can have the virtualized stuff, and you have, of course, cloud. When cloud came into being with AWS, Azure, GCP, Kubernetes came in, and now you have virtualized infrastructure. And that virtualized infrastructure allows companies to have a lot more flexibility over time, and thus making it easier to maintain, even though it's highly complex. We'll talk about that too, of some of the frustrations that have come out with DevOps, because DevOps is great. DevSecOps with security on top is a necessity, with software supply chain. But at the same time, coders got a lot more than they anticipated. Coders want to code, and now they have to do things around infrastructure, and they also have to do things around scaling. These need to be mental facets that they need to keep in mind when they're actually building their software.
All right, Bill, I want to ask you a curveball question.
Absolutely.
It wasn't planned.
I like curveballs.
Why would someone not go cloud native?
That's very, here's the thing, is that there are situations where they may not go cloud native, right? Where they might need to have a hardware-based infrastructure to support it. There are a lot of legacy technologies out there that cannot be ported over just yet. We do see this. We have a lot of companies that have more legacy-based, stuff where they're like, look, we want to get there. It's just operationally we can't. Or in some cases, there might be some use cases like we have a lot of government customers, right? We're in Platform One, we're in Iron Bank, and part of that is, yes, there are virtualizations that they do have, but there are some that rely on things like hardware-based encryption, right? For maybe high-scale items, for more safety and precautionary methods. And then in other cases, it might be more hardware-based too, where it might be a device-based solution or things like that, where you need to have a hardware base as opposed to an orchestrator or virtualization around it.
That makes total sense. Moving on to the actual next question that I was supposed to ask you. So one of the things that really jumped out to me was, when we looked at the top of the top most leveraged packages,
Correct.
Docker, Maven, millions of repos, just like tons of usage, right?
That's correct.
So, do we ever see these kind of younger or newer languages catching up in terms of adoption to the likes of Java? We've heard, is Rust the new Java? We've seen Cargo get a lot of adoption year
Cargo
over
is
year.
Rust, right? So yeah, when you have those together.
Yeah.
And absolutely. What's funny is that you mentioned that because, like I said, we got an old guy like me who's been doing this for a long time. I mean, I've been doing this, since, the late 90s, right? And the thing is, like, even back then, my company, we had the first web-based CRM product. So we were playing around with a lot of very infantile JavaScript, right? Because it allowed us to do a lot of browser-based stuff. But the thing is that, towards the end of like 2008, 2009, when we started getting into these eras and towards like 2010, NPM came about, right? NPM, its usage went through the roof. And the reason why is because you could do, as a developer, right? And this is one of the things, I actually built 2 companies based on this technology. The thing is, I was the founder of these companies that we did, but we built it and using NPM, using Node, because we could do front end and back end together, right? That was just eye-opening. And the adoption went up. So almost every website of this Web 2.0 era that came about, and then going into things like Facebook and Twitter and all these applications, all these apps that were out there on the web, were all built in this, right? And the reason why is because it was perfect for the usage, right? It allowed back-end manipulation of data, front-end presentation with pretty, with active, the ability, using Ajax when Ajax was new and all this stuff. And then it came about was, being able to actively update these websites. Now we see, this movement towards Rust. And why are we seeing a movement towards Rust? Is the thing is that it's got the power of C and C++, because it actually, C and C++ is operationally extremely fast. But Java, when Java came about, the reason why Java, because Java got rid of some of the problems of C and C++ with memory management and garbage collection. Well, Rust has actually inherited that, right? So Rust has garbage collection. Part of the compilation, because you compile it to run faster, is you don't need a runtime. That's the reason why when we talk about like IoT devices, why it's becoming so popular. But on top of that, it's thread safe. The tools actually go ahead and let you know if you're coding something incorrectly. Think about that. Back, you used to have to do this manually yourself, test it, make sure that, memory allocation and things like that were being handled. Rust does this for you. So the adoption of it is because it's easy to use, it compiles fast, lack of runtime. It can do everything from web development to device management to actually operational things that you might run on the server. It's actually, I've become a real Rust devotee.
I can tell a little bit.
It's amazing. Like, we actually just did the thing at Rust Nation, right? We actually, one of our guys, Stephen Chen here, is actually the chair of Rust Nation, right? And, of the Rust committee, of the Rust board. And the thing is that I think it's really interesting, right? It's a dichotomy that everybody has. It's like, you can't discount the fact that C and C++, to this day, 50-plus-year-old language of C, is still powerful, right? But the thing is, it has problems, and Rust went in to attribute to those problems and make it easier for people to do things at the scale and speed at which Rust offers with Cargo, and it's also package based. I mean, don't get me wrong, C and C++ has Conan now, which we brought to the world, but on top of that, Rust has the same idea, package management, which means that you can leverage other people's code to do your code better.
I want to ask a follow-up question to this before we transition into our next question. So when exactly do you think that usage of a language like Rust or Swift or one of these newer languages, when will they be at the same level as
when does it hit the event horizon?
Yeah.
Before? So I think that's the thing, is I don't think that there is a point. I think that one of the key, look at this. Like I said, I just mentioned C, right?
Yeah.
C has been around for 50 years.
And people still love C,
right? I mean, think about this: Python code, the Python code that SpaceX uses to launch into space, or they use Python, and the algorithms behind it are the same algorithms that were used for the Apollo program, right? But the thing is that they evolve, they change, the adoption is still there, and sometimes they attribute to trying to go ahead and become the next thing. But a lot of times these languages, I think, are just constantly evolving. They adopt. Something new will come out soon. In the next couple of years, I think Rust will find its place. I think there's other ones too. I think there's still a lot of room for movement. I still think that there's a place out there for somebody. I mean, we have like R and stuff for like doing ML and stuff like that, but I think there might be something better. I'm sure that there's people out there right now working on something better to accomplish the same task. They'll release it. It'll be a slow adoption. Somebody will find something that it fixes a problem on, and the adoption will go up, right? This is what happens. I mean, Rust is a very young language. It's 5 years old. It's just a little over 5 years old. And the thing is, if you think about it, for the first couple of years, it kind of had a little bit of stumbling, and then it ramped up. Right. And then suddenly people looked at it and went, oh, my God, these are all the things I can do with it. Wow, this is pretty amazing. And then people talk.
Yeah.
Right. Nerds like to talk about this stuff.
Totally.
I do all the time, obviously.
Yes, you do.
We
get Bill. we wheeled Bill out a lot from the marketing perspective. And we love
They pull me out of the dark, dingy room where they keep me and feed me, where I produce stuff.
Yeah. So you mentioned Conan before, and I think that's a good segue into the next question. And first of all, shout out to the Conan team. Conan 2.0 just dropped last week.
Diego and Luis, two of my favorite people, and their team are amazing. By the way, they are two people. We always refer to them as Diego and Luis, but they are two people.
Separate. If you haven't seen the news or checked that out, please read about Conan 2.0.
It really changes the game, by the way, in terms of C and C++ development. A lot of the problems that Conan, just C and C++ faced, some of the things that we recognize as being faults have been fixed. So definitely check it out. Read the docs. It'll make your life 10 times easier, especially if you're doing C.
Absolutely. So on that, C and C++, Edge, IoT, right? They've traditionally gone hand in hand.
Correct.
You can't hardly get a dumb device anymore.
Sure.
Like we've got a smart toaster downstairs in our office,
yes, we do.
Which scares me. So, what are you expecting to see in the world of IoT development? You touched on Rust a little bit, but let's double click on this area. What do you expect?
I've got a lot of background in this, right? So, I mean, I had a company back in 2006, 2007 when we started called For Home. We were actually IoT before IoT. Won a bunch of CES awards. We actually had to write our own platform to do this. A lot of the technology in IoT devices are actually that were patented. And when we sold the company that acquired us just wanted our patents. Because we had a lot of these. But the thing is like you said, IoT devices have really come to prominence. It's become such a blanketed term. Sometimes it really hits me weird to think, that IoT is now just all encapsulating basically any device that could be a smart device or a connected device. Like I said, we called ourselves the connected home before the IoT was a name. Mm-hmm. And the thing is that has evolved over time. If we go back to the catalyst for a lot of this stuff, everybody talks about Crestrons and all these things, the home of the future, really was the kickoff for it, but it's much more than that, right? It's industrial, it's automotive, it's anything, that it can be. But the thing is that there are certain constructs that are utilized throughout all of it that are still kind of standard, right? C and C++ are still low-level device things that you've used to program on PCBs and PCU boards and things like that for these devices. Rust is taking over, right? But some other ones like gateways, like home gateways, back, 10 years ago, 12 years ago, OSGI was the big thing, the Open Source Gateway Initiative. It was Java-based. You created jars with service functions. You would push them down to a device. It had this device framework, and they would run. Then certain devices, and then they switched over to Docker. actually. A lot of these device gateways and stuff like that use Docker, right? Because you can have small little busy box, images that are very tiny in their nature, and you can deploy services and whatnot. C has always, like I said, been the device portion of this, but that's actually being also overtaken by Rust because of its thread-safe nature and all those kind of things that really fix what C and C++ did, but also, too, the lack of a runtime. That's a huge thing for devices. That means it frees up space on those devices, where certain ones like Java, you need a Java runtime, right? You need to have a Java runtime to operate Java. So, C and C++ can operate natively inside. Same thing with Rust, right? It's a compilation. You compile it. It's small size. It has all the things you need in it. And the thing is, so as these number of devices increases, and we can actually go back to the idea of package types and the number of deliveries going up, because seriously, what is it? It's like, I think it's going to be 74 trillion something devices, or something insanely,
it's unfathomable,
like bazillion devices in the world. And the thing is that, each one, like you said, almost every device now is a smart device. Think about like the Apple Pencil, right? Or, it's in your hand, or, with me, I've got my, I'm wearing devices, you got your Apple Watch, I've got my Loop Band. These are things that I utilize, right? So the thing is that when you're a developer, you want to use, once again, tool sets that are really the best. And when it comes to IoT, C and C++ and now Rust are really the key components. And Conan 2.0 really actually helps a lot. Especially when it comes to the device management and stuff like that, because of some extra components that were learned, that were brought in for Conan 2.0. And then, like I said, I've seen a lot of companies that I work with in terms of education and on how to use our platform. I see a lot more, like I said, Rust to me is insane. I just cannot believe the quick adoption of this. It reminds me, like I said, of NPM. It reminds me of Java. It reminds me of, the hot language that's now. And IoT, though, managing those devices, managing the software updates is really essential. And we are a key factor in that as a platform, with the ability to go from developer to device and be able to actually travel through the entire SDLC, software development lifecycle, the entire journey. So it's pretty amazing. I love the industry I chose to get into early on in my career, because it's constantly evolving. It's constantly changing. You always have to learn something new. If I was doing like a standard desk job, I would probably go out of my freaking tree. But at the same time, it's like I love the ability. I love that the fact that we're in an industry, as you said, coders are artists, and I love being surrounded in the world of Da Vinci's. These people that are just build stuff and create, and it's all about creating art with the form and function that you need, and then using the proper tools to do it. Like, if I'm going to sculpt a statue, I'm not going to use paint, right? So like I said, it's always the appropriate technology for the thing you're trying to do, and then trying to build that is exciting.
Totally. All right, Bill, before we get into my next question, I just want to remind everyone out there watching us, if you have other questions, we've had some come in that I've been able to pepper in here for Bill, keep him on his toes. If you have any other questions, now is your time. We're getting close to the end of our stream here. But Bill, one thing that recently came up in recent news, I have an article link here. I don't know why I dropped the article link, as if I'm going to show it to anyone, or spell it out. There's an article link here.
He's just going to give me a in my head for that browser I've built into my skull.
But essentially,
Neuralink. No,
yes, U.S. officials, a lot of people are asking organizations to look at how their practices and using memory safe languages and that sort of thing. Obviously, we had S-bombs recently. It seems like more and more we're getting, government agencies, these official bodies being like, look, software industry, developers, technology companies, we need you to help step up and deliver more secure software.
Absolutely. It's the biggest threat to software right now is the software supply chain.
Yeah.
Right? 2021, there was a 650% increase in software supply chain attacks. Last year, there was a 40% increase on top of that. Think about that. That's, And the reason why you brought up SBOM, right?
Yeah.
And that was actually part of the May 2020 initiative by the actual government to say, let's go ahead and fix the nation's cybersecurity, security. Actually, it was Section 4 of sad, I know that, but Section 4 defined securing the software supply chain. Remember, 85 to 90% of the stuff that software developers use to build what they're doing is someone else's.
Yeah.
Right. My favorite quote is that every time you do a pip install, you do an npm, install, whatever, it's the equivalent of finding a USB, key on the street and plugging it into your production server.
Yeah.
Right. Now, the thing is that actually this goes back even farther than that. This goes back to 2018 with the Food and Drug Administration. Because think about it. Let's go back to IoT devices, right?
Yeah.
IoT devices, pacemakers, ventilators, right? These are all devices that run on software. And the thing is that the reason why it was put in place initially before the Biden administration jumped onto it was the fact that, devices can kill. These are things that keep people alive.
Yeah.
And if the software that you're building has, stuff in it that is potentially nefarious or malicious, right? I mean, you literally can kill somebody, right? And the thing is that, or launch missiles. Let's think about all the deadly things that software is used for, right? There's the altruistic, there's that, but of course, there's also the defense industry. There's also other things like that. Well, if let's look at something like SolarWinds, right?
Yeah.
That was a 4th level transitive dependency attack, right? It came in associated to other pieces of software, right? Other dependencies. It was an indirect transitive dependency, not implicit, right? That caused, 18,000, companies globally to be affected. I mean, think about that. That's insane. It was $100 billion worth of remediation globally. It affected governments.
Yeah.
And the thing is that was really the wake-up call to say, yeah, this could be very serious. So the thing is, making sure that you do things like shift left, right? Give your developers the ability to still do the creativity that they do, but still ensure some level of security by making sure that those dependencies that they use are safe. And I mean, compliant. They're not typo squatting. Typo squatting is where, somebody out there has created a nefarious package with an E before I instead of an I before E in the name, right?
Yeah.
Things like that. Making sure that, not only is it just up front and shift left, at the developer, where actually, by the way, just so you know, it's actually where you get the maximum ROI. It's 100 times more expensive to fix in production than it is to actually do it at shift left. But also maintaining that entire security structure through the entire process while you're doing it is also essential. And even after the fact, and the software bill of materials, all that does is provide a list of ingredients to your customers or to the government to say, these are the things that I use. And some companies have exclude lists that when they go through, they'll go through it and say, oh, by the way, we don't accept this license type, or we don't accept this software type because it's been reported that it blows up the world.
So then it seems like with all of these security focused initiatives, is that going to impact the technologies that certain companies might use in their software supply chain?
Oh,
we're only going to code in this, or
it shouldn't, but it does. So the thing is that sometimes the people who make these decisions, might not have the full picture, right? And it might be very knee-jerk. They read an article and they say, oh my God, we need to stop using this because of a potential threat, without analyzing or understanding that potential threat completely. And the thing is that making sure that you have all the pieces attributed to, and putting in software tooling that allows you to go through and make sure that those components are safe and secure should alleviate that. One of the things that we're trying to do here at JFrog is, of course, that we have our product that goes end to end, right? Provides that level of security to make sure those binaries that you're using to build your software, those transitive dependencies, are compliant, they're safe, they're secure. So this way it allows you to have a little bit more ease, allows you to do more time on innovation and less time on remediation, right? The more time you remediate, it costs you more money because you're not able to get those features out faster, right?
So I'm hearing you say that you can still have the flexibility and you can still deliver secure software if you have the right practices.
Just make sure you have the right technology to back you in that respect. Make sure you have make sure that you're evaluating all the things that you're using before you give it to your customers or deploy it into your production or whatever.
Cool. All right. we're just about at time for our stream, so that means it's the final question. And Bill,
5 seconds on the clock. Wait, oh, sorry. No, that's a different thing.
This is one of your favorite.
Oh,
let's look into Bill's crystal ball. And where do you see, software development going over the next year? So that when you and I sit down again next year, what are you going to be talking about then?
I've been talking about it a lot, and I see you smiling because I've been yelling about it for a while. Platform engineering, right? Companies are, DevOps is still king, so DevOps will still be there. But the idea of consolidations of tool sets, becoming, giving developers more time to develop, removing a lot of the things that they had to do around infrastructure and whatnot, consolidating the tools into more simplistic tools. So instead of the sheer vast number of tools that came about during this growth period of DevSecOps and DevOps, we're going to see a retraction of tools, more multi-purpose, right? I think more simplification of tool sets and tool chains. So this way, and standardization across companies, as opposed to before, giving each team the ability to use whatever technology they want. It became a little unmanageable for ops teams and whatnot, more responsibility on developers. I think you're going to see retraction of that. I think you're going to see it become more automated. I think you're going to see less tools, more base fundamental tools like our JFrog platform, right? It's end-to-end. It's a great base foundation for all of that. You can, use other tools that you want to use to do this. But I think we're going to see more platform engineering take purpose where developers can do more developing as opposed to less operational, right? So they want to pull back more operational stuff and do more development.
So maybe it's like flexible standardization.
Exactly. I think that's what we're going to see more of a push towards,
Gotcha.
Especially with the recession coming up. It's going to be more of a retraction of tool sets, simplification, and expedite it, and also more automation, more things that take it out of the developer's hands and have it do it behind the scenes, like use metadata to create things, as opposed to having to do any sort of manual process.
Awesome. I mean, I think that'd be great for everyone. I'm sure everyone would be thrilled if that happens.
I guess where we're going.
Remind me for this time next year, and we'll see if Bill's prediction came true.
See you in 2024.
Oh my gosh, it's weird to even think that.
Yeah.
Cool. With that, we are over time. Bill, thanks so much for sitting with me, for having this conversation. Are we going to fist bump?
We'll fist bump.
And thanks everyone for joining us. We hope to see you again. If you like this stream, let us know. If you have feedback on the report itself, we're going to be running this report annually. We're looking to improve it. You can drop us some comments, your thoughts at pr@jfrog.com. Yes, that'll go to our comms team, but they love to hear from you, and they will feed all of us the feedback on that. Thanks everyone for joining us. Bill, thanks again. Always appreciate
Sean
time
in the morning.
We'll see you guys next time. Bye.
Cheers,
everyone.
everybody.
Thanks
be
for
safe,
joining
be
us.
wonderful, be well.